Good morning, students. How are you all? So I think the part 1 has understood class 9 standard. Motion I have taught in the beginning up to that acceleration, right? So all I have taught in the beginning. What things I have taught in the beginning means you know that already. The first things rest, motion, physical quantity, scalar quantity, and vector quantity, distance and displacement, and distance and speed also I taught. Similarly, I have taught that what I have taught that. So velocity also I taught, and average velocity, average speed formula both I taught. Even types of motion in that, uniform motion and non-uniform motions, and even I taught the symbols and up to that accelerations. Right? In that acceleration I told you that is maybe positive and negative, but here I am going to explain the positive and negative. This is for positive acceleration, first one. So here listen. What is positive acceleration? Listen. When initial velocity is lower than final velocity. What is saying? Initial velocity, starting velocity. Starting velocity is lower than final velocity. For example, I have taken, you can't understand, that's why I took an example. Initial velocity u is equal to 20 meter per second. Per second. And final velocity v is equal to 50 meter per second. And time is taken also, that is for 5 seconds. Right? According to that, we have taken the 3 value, and according to this formula, acceleration is equal to v minus final velocity minus initial velocity divided by time. Right? So, initial final velocity v is 50, minus sign is there, minus, and initial velocity is 20, divided by time is taken, that is what? Time is 5. Then 50 minus 20 is 30. That is a is equal to 30 divided by 5. We can cancel 5 on the 5 6 30, and we got a is equal to 6 meter square per second. This is the positive. We got the value of positive only. This is for positive only, positive acceleration. Similarly, I took that one negative acceleration also. Listen, negative acceleration is when initial velocity is higher than final velocity. Initial velocity is higher than final velocity. For example, I have taken here initial velocity is equal to 100 meter per second, and final velocity is v is equal to 60 meter per second, and time is also taken, that is for 4 seconds. For example, I have taken. So that acceleration is equal to v minus final velocity minus initial velocity divided by time, and final velocity is 60 minus initial velocity is 100 divided by time is 4 seconds. Right? So 60 minus 100 or 100 minus 60, this is the bigger value is minus sign. A is equal to minus 40. 100 minus 60 is 40. This is bigger value is minus sign, minus 40. Divided by time is 4. We can cancel 4 ones are 4 and 4 tens are 40. This is the minus sign should as it is. A is equal to, that is minus of 10. The denominator 1 should be put as it is. A is equal to minus 10 meter second meter per square second. These are two things we have done in the acceleration, which is positive acceleration and negative acceleration. Positive acceleration, what it will say, initial velocity is lower than final velocity, right? And in negative acceleration, when initial velocity is higher than final velocity. We got examples also in this form. Now I am going to explain, this is the main important point of that, graphically represent of motion. Graphically representation of motion. First one, distance time graph. Distance time graph, uniform speed. You know that uniform speed is important. So here speed is increasing, time is also increasing, velocity is increasing, time is also increasing. See here you see. For example, this A, this is one we are taking the velocity, and the time is also here extending 0 to here. And similarly up to B, we are taking that B, that is velocity is also increasing, and time is also increasing, extending the time. This is the time, right? So this point, we are taken that point T1, and second one is B, that is T2. Similarly, the distance is taken for that velocity is distance is S1, and similarly the B, that is S2. We have to fall in the mathematically, we have to solve. Uniform speed or velocity is equal to v is equal to general form is s by t, right? So distance divided by time. V is equal to velocity is equal to distance divided by time. The s is distance, don't get confusion. S is distance and divided by time. V is equal to general form. S is distance. Distance is how much? Distance is s2 minus s1. Full length is full length minus second length. V2 minus V2 minus initial point. This is initial speed, final velocity. How to take V2 minus V1, right? V2 minus V minus U divided by time 2 divided by time. This is final velocity divided by final time divided by initial time. So S2 minus S1 divided by T2 minus T1. This is the velocity of the finding that. Again, in the uniform speed. Uniform means it is the speed is equally it will going. We can find out easily. We can that. Right? Non-uniform speed or velocity means this will go in the direction of maybe this side or in zigzag or like that. This type of will give curves, or maybe it will give increasing the velocity of that. This type of also we can, it will go in a speed of the object, right? So the graph will presented of this is a uniform speed. This is for non-uniform speed of velocity. Understood? Next, I am going to explain the main points of the three equations should be there. We can prove here in that which one means equation of motion in graphical method. First one is equation of velocity time relation. That we have to explain. I will write and explain to you all. Now here I am going to explain what that is for equation of motions by graphical method. In the first that three equations should be there, and I have done the first equation. I have solved equation of velocity in time graph. This is first one. So graphically method we have solved equation of velocity time in relation. This is u is equal to v is equal to u plus at. This we have to prove, right? V is equal to u plus at we have to prove. This is the graphically represented. See, this is the AB. This is the slope. AB we are taken. This is E, and this is x-axis. This is y-axis. This is time. This is velocity, and initial velocity starting that is u, and final velocity that is v. The slope is taken, that is AB. This is the slope we are taken from here to initial velocity to final velocity up to here. The final velocity up to reach here, that is v, and d is the distance. This is the time which has taken from u to v, the final velocity, and here a and t also taken, right? So here slope is equal to the general formula, slope formula we have taken. Slope is equal to rise by run. Rising. This is the slope of rising up, and running. The time is running. Slope is going up to cross, up to the time is taken. How much? This is what take. So here AB is equal to slope is AB. Slope is how much? Slope is a what? Slope is AB. Slope is AB we are taken, and rising what? Rising up to height. What is the height? That is BD. This is the height of that. Height is BD. And AD, what we are taken the time? Time we are taken, that is for run. Run is taking time. This is here to here. The distance is maximum. The height is up to that B. AB is rising and AD is run. That is for time. Here also time. Right? Time. And AB is equal to BD by AD. First I will tell that here. First things, BC is full length of the V. BC is full length of the V. The BC is full length. This up to here 0 to B. BC having equal parts. That is one part is BD plus BC or CD. We can take this part and this part we are taking into that. In BC full length, the half of the full length is BD plus CD. BD plus CD, the full length is BC. The BD plus CD are the half of the this is we are taken. And if I CD is transpose this side, BC minus CD plus CD, if I transpose this side, it become minus sign. BC minus CD is equal to BD should be as it is. BD should be as it is. Right? And one more thing, AB is a acceleration. What we are taking? Acceleration. The acceleration, that is for velocity of the speed of velocity. Acceleration is A. Small a we are taken here. That is A. So similarly, here AB should be as it is equal to as it is BD. What is BD? BD value is what? See here BD is BC minus CD. BD is BC minus CD, and divided by AD should be as it is. After that, A value we have taken this. AB is what? AB is acceleration. AB is acceleration, the velocity time graph, that is for speed or velocity. That is AB is A is equal to BC. BC is what? BC is full. What is that? 0 to here. What is that? Final. That is velocity. Final is velocity. Minus. That is a CD. CD is half. What is 0 to here? U. U is initial velocity. Final velocity minus initial velocity. Final velocity minus initial velocity divided by AD. AD what you have taken here? What is taken here to here, here to here? The same. Both are parallel and equal also. Here to here is what? Here to here is what? Time. That is for time we have taken. Now after that we have to cross multiply. We have to cross multiply this part. A into T, AT is equal to B minus A. Minus U, if I transpose this side, it becomes plus sign. This is minus U if I transpose this side. After that, before the is equal to, if I take, that is plus. AT plus U. Minus U if I taken, there is plus U is equal to V. Right? And we can rearrange, no problem. V is equal to U plus AT. U plus AT. We have proved the first equation of that velocity time relation or velocity time graph. Understood? Now similarly the second equation I am taking. Equation of position time relation. Position. First one which one I have taken? First one which one I took? Can you tell me that? First equation is I have taken equation of velocity and here equation of position. Listen there. Three equations are very important. See. So I have taken area under slope. Under slope. Under the slope. Slope is here. See. Under the slope. Below the slope. I have done the line. See here. Under the slope, what it may be the area we are finding. First, two things will be there. See here. This is one triangle and this is one rectangle. See, can you assume there? Two things are there. Area of O, A, B and C. This is the under curve area. Right? So, first, area of rectangle. Area of rectangle OADC. OAC or OADC. No problem. OADC. OADC. First, this is one rectangle. Under the curve. And another one is, this is first part. This is second part. Plus, under the curve means two things are there. One is triangle, one is rectangle are there. Area of rectangle AOCD. No problem. This is AOCD we can take. Okay. AOCD we have here. CD plus area of triangle. This is the above triangle. Triangle. This is the triangle we have taken. Triangle. What we have taken? ADB. This is the second triangle. One is rectangle and triangle. According to the area of OABC, is this a displacement? Yes. Displacement, yes. Is equal to area of rectangle is equal to formula what? Length into breadth. This is the length into breadth. Plus area of triangle is equal to half into base into height. Area of triangle is equal to half into base into height. Similarly, S is equal to displacement short form I wrote S. That is for S. Length. What is the length of the rectangle? Length is OC. This is the length, this is the breadth. Rectangle, you know that. Okay? Length into breadth. Length is how much? Length is OC. OC or AD, no problem. That is OC. Length into breadth. Breadth is this. OA. OA or DC, no problem. OA we are taken. Plus triangle. We have one triangle. See. Half into base into height. Half into base. What is the base? Base of the triangle is AD. Base of the triangle is, this is the triangle. This is half into base. Base is AD. Into height is BD. This is the taken of the BD. Right. After that, S is equal to OC. OC is what? OC is what? Time. T. OC is T. And OA. OA is what? Up to here. O to A. What is in here? Initial velocity will be there. Initial velocity U. You remember here V. This is U. This is V. Okay. OA is U. Plus half. And AD. What is AD? AD is also what we have taken? Time. This is equal to this. Time. Time T. That is into BD. BD is what taken? BD is what we have taken. See, BD is what here? We have to just assume here. BC is the full length and BD plus BCD are the two parts of the BC. Two parts of the BC. BC is full length. This half part and this half part we are considering as a full length. That is for BC. If I transpose this CD here plus CD, it will come minus BC minus CD is equal to BD. What is the BD of BD? BD is BCA minus CD. BC is BD minus BC minus BD is BC minus CD. What is BC? BC is V. BC is V. Here you see the V and CD is what? CD is also U. So final velocity minus initial velocity we are taken V minus U. V minus U. See here V minus U. So I have put it in this form. After that, from the above equation, first equation I have solved. What is the formula we have done? V is equal to U plus 80 half. U plus 80. U plus 80. And if I transfer this side, it will become minus sign. V minus U is equal to what we got? 80. So here I will replace this V minus A. V minus A I will put and changing the replacing the value of 80. V minus A I will replace and I will put 80. Understood? See, S is equal to U into T, UT plus half as it is T as it is. V minus U. V minus U I will replacing that is for 80. Right? S is equal to UT plus half 80 into T, that is for 80 square. This is the second we have solved. First one we have solved U is equal to V is equal to U plus 80 and S is equal to UT plus half 80 square. This is the second equation represented in the graphically we have solved. Next one, the last one is here and I will explain this also. Let us wait. Now I am going to explain the third one, that is for equation of position into velocity relation. Velocity relation. This is the third one. Now the rectangle is not there like that, only the trapezium will be there. See, one side, two side, first side, second side, third side and fourth side. This is the trapezium will be given. See, area under slope is equal to displacement is equal to area under curve in the displacement of curve inside the trapezium. What will be the four-sided figure will be there. Under the curve we are finding area of OA, B and C. Similarly we have taken area of, this is the slope we have taken. Area under slope is area of a trapezium, four-sided figure OABC. This is equal to, that is half of, according to the area of trapezium is equal to formula we have taken. Half is equal to this length of that BC plus OA. BC plus OA. This is final velocity plus initial velocity into time. This is final velocity plus initial velocity divided by time into time is OC, right? And this is the trapezium we are taken, yes, that is for displacement of that. So we are taken that is a, so under slope is, that is displacement. Displacement is nothing but yes is equal to half. BC is full velocity, final velocity, that is V, plus OA is initial velocity U into OC. OC is here, OCC, that is for T time. That is for time. So here S is equal to half V plus T into T. T we are taking the equation 1 from the equation when we are taken from 1. See here, I am working in the equation 1 from 1. What is the equation 1 we are taken? U is equal to U plus V is equal to U plus 80. If I transpose this, it will become minus n. V minus A, the product value I will take denominator. Then V minus U divided by A is equal to the remaining part of the time is T. If I take on this side, it becomes, don't get confusion, minus V. Minus V minus U. Then divided the product value is equal to 80 left. And 80, the A value I transposed to be there, the value of T is, we will get V minus U divided by A. I have in place of T, I have replaced that is V minus U divided by A. So similarly, S is equal to, this into this I will multiply 1, this 2 into A, 2A, V, A plus B, this is the form of, you see, A plus B formula. So here A minus B, the both are in bracket sign and multiplication side here, we will get A square minus B square, already we know the formula. A plus B into A minus B is equal to A square minus B square. So S is equal to 1 upon 2 into A, 2A. A plus B into A minus B is equal to A square minus B square we have taken. And S is equal to cross multiply we have taken S into 2AS. 2 into AS, 2AS is equal to, what is the left? 1 you drop it. And multiply same we will get value. 1 into V square only, 1 into V so minus 1 into U square only, V square minus U square. And we can rearrange in that, or we can rearrange in that V square minus U square is equal to 2AS. This I should here that transposing this side. This is the second equation, and according to that, this is the third one I have done after that is for equation of position velocity relation, or position of velocity relation. This is the third one. I am explaining that one that I have done at that also. That is V square minus U square is equal to 2AS. This is the topic I have done on that. This is the motion chapter. This is the part 2 I have done. You can watch it. Okay.